Welcome to Virtual Math Masters. I'm your boy, Master Cruz, so you never do math alone again. And today we're going to talk about checking solutions to inequalities. So let's jump right into it. Example 1 says 8 plus a is less than 12. If you have any questions or you're not sure which inequality is less than or greater than, please watch my previous video on Introduction to Inequalities. It will be a great help and it has a lot of hacks. But in this video, we're gonna focus on checking the solutions. So which a value or values satisfy the inequality? So there could be more than one. That's why the S is there. And they have three options. It's a equals 3, a equals 4, and a equals 5. So we're gonna start with a equals 3. How do I check if 3 is a solution to this inequality? Well, the first step is to substitute. And the way that we do that is we're going to take this 3 and we're going to substitute into the a value because they told us that a equals 3. So I rewrote the problem down here, but instead of writing a, I'm going to write the number 8 plus, instead of writing a, I'm going to write down 3 is less than 12. And I'm going to simplify and check if I get a true statement. So how much is 8 plus 3? Well, 8 plus 3 is 11. So on the left-hand side, I'm going to get 11 is less than 12. And the question is this true? Is this a true statement? And the answer is yes, absolutely. This is true. Therefore, a equals 3 is a solution because 11 is less than 12. A cool hack that you may remember is that the alligator or Pac-Man or whatever you call it eats the bigger number, right? So in this case, this is saying that it's eating 12. However, you need to know, because we're in algebra now, you need to know if it's less than or greater than. So in later problems, you can get it right. So let's try the same with a equals 4. I'm going to substitute a equals 4 into the same inequality. So all I have to do is rewrite the inequality a plus, but instead of writing the a, I'm going to substitute the a with 4. And then that's less than 12. I'm repeating the same steps from here, but I'm not rewriting this. I'm just replacing the a with the 4. And then 8 plus 4 is 12. So this is 12, which is less than 12. And the question is this a true statement? Is 12 less than 12? Well, the reality is that 12 equals 12, but 12 is not less than 12. So in this case, the answer here is no, this is not a true statement. Okay, now if, and this is an if, right? If you had that 12 is less than or equal to 12, then this will be a yes, right? This will be a yes, but that's not what the problem said. Therefore, the answer for a equals 4 is no. But know the difference. No less than sign, no, is not a solution. Less than, no equal to sign, less than sign alone is not a solution, but with the equal to sign, it will be. The last is a equals 5. Well, if I plug in a equals 5, then 8 plus 5. Maybe you could do this one before I do it. Try to get, if you get the solution, the answer correct. 8 plus 5 is 13, and 13 is less than 12. Is this a true statement? Is 13 less than 12? The answer is no. In fact, any other number that you go above a equals 5 will always be no. Only the answers or only numbers are less than 3. The answer will be yes. So that's how you check if a value is a solution or not. Let's go to example 2. Let's go to example 2. Example 2 is a little bit different. It says m squared plus 2 less than 6. How can you check if this is a solution? Well, again, you could follow the same steps of substituting the numbers. However, for the first time that I'm going to solve this, I'm going to do it a different way. If you have solved linear equations, actually, if you have solved linear equations, hopefully, right? Let's just plug it in. So if you have -4 over here and we plug it in, let's substitute. Instead of the m, hopefully you know that this is -4. We're going to write -4. And then we're going to open that parentheses, all squared plus 2 is less than 6. So I'm going to do this for -4 first when a equals -4. Now, we got to follow PEMDAS. So exponents first. Negative 4 squared is negative 4 times negative 4. And negative 4 times negative 4 is positive 16. So this will simplify to positive 16 plus 2 is less than 6. And when I add them, I get the 18, right? 18 is less than 6. Is this a true statement? The answer is no, this is not a true statement, okay? Which means that A equals, I'm going to write right here, A equals negative 4 is not a solution, okay? So A is not correct. A is not correct. Let's try B. B says, B is for M equals negative 2. So what happens if I plug in M equals negative 2 in the original problem, which is up here, right, in the original problem? Well, again, I'm going to open my parentheses where I see the variable plus 2 is less than 6. But this time I'm going to plug in negative 2. And if I plug in negative 2 in here and I simplify, the negative 2 squared means negative 2 times negative 2, which is positive 4. And positive 4 plus 2 is less than 6. That's what that says. And then 4 plus 2 is 6. So 4 plus 2 is 6, which is less than 6. Is this a true statement? Just like we did in the previous problem, the answer here is no. 6 is not less than 6. 6 equals 6, which means that B is not correct either. Okay, B is not correct either. So let's cross it out. What happens if you plug in 0? Well, if you plug in 0, I'm going to rewrite the problem again. All square plus 2 is less than 6. But now I'm going to try M equals 0. So I'm going to plug in 0 here. Well, 0 squared is 0. This just cancels, right? And you get that 2 is less than 6. Now, this is a true statement. 2 is less than 6, which means M equals 0 is a solution, and C will be correct. If you plug in positive 2 or positive 4, you will get exactly the same answers as we did here, because when you square it, you will get positive 16. When you square it, you get positive 4. So the answers will be no. The only correct answer is C, it's 0. So this is how you check. This is how you check if your answers are correct. So example 3, and this is the last example. What happens if I give you a linear equation, an inequality that has X and Y? And I ask you, are the following point solutions? Well, what you have to remember is that, I have this double over here. What you have to remember is that the first number of a point or coordinate is always X, and the second number of a coordinate is always Y. Hopefully you remember something like this from middle school. So this is always written in alphabetical order, okay? Always written in alphabetical order. So the first number is always X, the second number is always Y, and I'm just going to substitute. So whenever I see a number next to a variable, I'm going to open parentheses, right? So what I'm going to do is that I'm going to plug in Y. So Y is negative 3, and negative 3 is less than 3. I see a variable next to a number, so I'm going to open a parentheses plus 7. And then I go back and I plug in what the X is, which is 4. So all I did is that I replaced the Y value with negative 3 and the X value with positive 4. Okay. And now I'm going to simplify and check if I get a true statement. So if I keep writing down, this is going to be negative 3 is less than, and then I multiply these two, right? 3 times 4 is 12 plus 7. And I continue using my order of operations. So this is going to be negative 3, right? Negative 3 is less than 12 plus 7 is 19. And the question is this a true statement? And the answer is yes, this is true. This is a true statement. So therefore, what that means is that this point A is a solution to this inequality. So this is a true statement. This is true. So this is great. This is perfect. Let's try B. How about B? Well, I need to plug in 0 and 10 in here. How do I do that? Well, I need to label the points. If the points are not labeled for me, I need to label it. But now I know that it's always X comma Y because this is an alphabetical order. Also, you always find out that you have an X first, then you find out Y. So It usually works like that. So instead of writing, I'm going to copy paste the same thing, right? I'm going to write y less than 3x plus 7. And then wherever I see the y, I substitute for 10, which is less than 3, open the parentheses, plus 7. And instead of writing the x, I'm going to write 0 right here, right? Because that's what the x value is 0. This is actually very easy. Hopefully you can see that because 3 times 0 is just 0. So this cancels. This is 0, and you just bring the 7 down. And that's it. This is the statement. 10 is less than 7. The question is 10 less than 7? This is actually false. That is not true, which means the answer here is no. That's a false statement. So the answer here is no. This point does not make this inequality true. The last one, we're going to do it real quick. Same idea. You start with -5, less than 3, open parentheses, plus 7. And you're going to plug in 2 for x. And then you simplify everywhere. You get -5 is less than 6 plus 7. So that says that -5, that a negative number is less than a positive number. I don't have to think too hard about that one, right? The answer is yes. You don't even have to finish this if they don't ask you to. You would just know, right? A negative number is always less than a positive number. So that's how you check if a point, if a coordinate plane, or just a number given to you is a solution to inequalities. If you feel like you need extra help, please click the link below. Visit us at Virtual Math Masters. I'm giving you a free tutoring for 1 session so that you could check it out and get the additional help that you need. I'm your boy, Master Cruz, so you never do math alone